everyone, today we'll be looking at a problem that was asked in IITJAM Physics 2014 question paper, which focuses on rotational mechanics. Now let's read out the question. An observer is located on a horizontal circular turntable which rotates about a vertical axis passing through its center with a uniform angular speed of 2 radians per second. A mass of 10 grams is sliding without friction on the turntable. At an instant when the mass is at a distance of 8 cm from the axis, it is observed to move towards the center with a speed of 6 cm per second. The net force on the mass is seen by the observer at that instant is. Well, in order to understand the question, let us imagine ourselves as the observer who is sitting on the circular turntable, viewing an object of mass m that is moving towards the center with a particular speed. So let's draw the situation and analyze it much better. We are the observer over here, a non-inertial frame, and we see an object. This is the axis, so we see the object of mass m. In the question it is given as 10 grams, so we have it moving towards the center as per the question. So we know that a rotating body will experience two forces. One is towards the center, which we know that it is named as centripetal force, and the other one is the Coriolis force, which acts tangentially. So we have two forces, one in the radial direction and the other in the tangential direction. So from the given diagram we can thereby confirm that the angle between the two vectors, the two force vectors, is 90 degree, which will come into use when we resolve the two vectors. Let's take the Coriolis force to be F1 and the centripetal force to be F2. So we know that Coriolis force is given by minus 2m into omega cross v, and F2, which is nothing but the centripetal force, which is given as m omega squared into r. So these two are the formulas which we will be dealing with. We have the omega, which is angular velocity or angular speed, as 2 radians per second. We have a mass of 10 grams. We have a distance which is r, which is of 8 centimeters, and a constant speed which is given as 6 centimeters per second. So our objective is to find the net force on the mass as seen by the observer at that instant. The observer is viewing such an occasion from a non-inertial frame of reference. Okay, now let us substitute our values and let's find out F1 and F2 and later resolve it using vector resolution. So we have F1 firstly. It is going to be minus 2 into 10, which is given in grams, so we have to convert it into kg or SI unit. So 10 into 10 to the power minus 3 into omega is given as 2 radians per second into v is 6, and as it is given as 6 centimeter per second, we have to convert it into meter per second. So let's multiply it by 10 to the power minus 2. On further calculation we will get something as minus 240 into 10 to the power minus 5 Newton. So we have the Coriolis force. Now let's go to F2, which we have mass as 10 grams, which is converted into kg into 4, 2 into 2, 4 into r, which is nothing but 8 into 10 to the power minus 2. This, on further calculation, we get 320 into 10 to the power minus 5 Newton. So we have F1 and F2 with us. The angle between the two vectors is 90 degree. So by the formula of vector resolution, what do we know? We know that p square plus q square plus 2pq cos theta is how we resolve a vector. So here we have the theta to be 90 degree. So this 2pq cos theta element, which is going to be 2f1 f2 cos 90, is going to be 0. So therefore we can directly write it as f1 square plus F2 square. So just substitute the given values. So 240 into 10 to the power minus 5 whole square plus 320 into 10 to the power minus 5 whole square. Now on further calculations, F net is given as 0.004 Newton. So hence we can solve such a problem by just making sure that we use the right formulas and perform the correct calculations that are required.